Let's kick off today by redoing a little bit of what we did last time at the end of last lecture, but better. And if you're watching the webcast and you weren't in lecture, then you'll never know about the not as good version. All right, so we're going to talk about another way to do implementation inheritance, namely using the extends keyword. And so the basic idea is pretty simple. Before, when we had a class that was a hyponym of an interface, for example, slist versus list61b, we used the implements keyword to say, by the way, an slist is a list61b, and therefore it inherits all of the interface of list61b and any default methods. Now, if instead you want to create a class which is a hyponym of another class instead of an interface, you use extends. Okay, so if white here represents interfaces and green is actual classes, then extends is what we're going to use to say that this thing is a subclass of slist. Right? So what we're going to do is this next little exercise is we're going to build a class called rotating slist, and what it's going to do is it'll be just like an slist. It does everything an slist can do, but it can also do a rotate right operation. What does that mean? Well, suppose we have a rotating slist, which is 5, 9, 15, 22. Those are the numbers in it, and we rotate right. Well, all those numbers should move to the right, and 22 is going to come around to the left. Okay, so that's rotation. Right? Oops, spoiler. So what we're going to do is we're going to use IntelliJ today. And the reason is I want to highlight certain features that you get out of an IDE. So rotating slist here is going to, we immediately, when you open this file, we can see that this file will not compile, and this coloring here, this red, means these are problems with our code. We can hover over it, and it says cannot resolve method. That's the kind of thing that I want you to pay attention to as this video is going on. Okay. So our goal is to implement rotating slist. The problem with it right now, if we look at our main method, is, well, we can create a rotating slist. This should be fine, given the syntax, but there's no insert method. Notice we have no insert method here, because we have not yet said that this is an extension of the slist class. So the first step of this is easy. We're just going to say extends slist item. And at that point, the slist class gains all of the privileges of the rotating slist class gains all the privileges, powers, and so forth of an slist, right? Notice that as soon as we do that, all of these things become a nice color, right? That's saying, okay, we know how to actually insert. But rotate right, of course, that's not an operation of an slist. So if we go to slist.java, you can scroll through it and see there is no rotate right, because we've never written one. Okay. Well, easy enough. We'll do public void rotate right. And at this point, we just need to write code that does rotating right. Okay, so how do we do that? Well, because a rotating slist is an slist, we can use all the methods that exist in an slist. So if we want to, for example, move this item from the front from the back to the front, then the first thing we need to do is get that back item and remove it entirely. Okay, so I'm going to say item hold back equals, and now I'm going to say remove. Nope, see, it's not quite working. Another good thing about ADE. So we have this inconsistent naming between what we're doing in lecture and what we had in project 1. And this, of course, happens with real libraries. So one thing IntelliJ will do for you is it will actually give you suggestions of methods. In this case, delete back. Okay, that's what I'm looking for. Great. So now what I can do that I have old back lying around, I can say insert front old back. And at that point, I think that should be it, right? You delete the last item, it's gone, and you put it back at the front. So now if we run this code, it should work, probably. Okay. So we do rotating slist, and here we go, 13, 10, 11, 12. This is what we expect, okay? So we've written rotating slist. Good job, us. All right. So this is all rotating slist is. It extends slist, getting all of its powers, and then we add this additional method. And so because it extends, what the extends keyword does is it means that the rotating slist class inherits all the members of slist. Okay? What's a member? Well, a member is any variable, instance and static variables, any method, and any nested class. So what's a nested class? Well, that is like, for example, if we look at slist, we of course had our old node class, right? So you inherit the node class. Okay. Now, one thing I'll note is that some members, if they're private, then the subclass cannot access them. So we could not, for example, start messing with a sentinel inside one of these methods. But that's something we're going to talk about more after the midterm. Okay, so don't worry too much about how private interacts between subclasses and classes, because I want to focus on the most important parts about inheritance now. We'll talk about those smaller details later. Now, one important point that I actually, in lecture, by the way, I don't know what happened in a lecture. It was weird. I used super in a strange way, and I don't know what happened. It was weird. Wow, I just kind of like repeated the same thing twice, sort of a Marco Rubio moment. But anyway, all right, so constructors, they are not inherited, right? You do not get the constructor of slist whenever you create rotating slist. Okay? This, just saying extended, you don't get the constructors. And we'll see what that means in more detail with another example now. So what we're going to do is build a version of slist called vengeful slist. Okay? And what it's going to do is remember all of its fallen comrades. So if I insert the numbers 1, 5, 10, and 13 into a vengeful slist, and then I delete 2, it will remember that these 2 guys that used to be at the back, that they have been destroyed, and at any point you can ask it to print all of its lost comrades out there. It remembers, and it will take revenge someday. Okay? So how do we build this class? Okay? Well, this will be a little more involved. So we're going to open up vengeful slist. Is this the right one? Yes. Okay. All right. And so now that we have vengeful slist ready, let's uncomment this. And we see immediately, again, as before, a vengeful slist at this moment, because we haven't extended anything. It doesn't have any of the powers of an slist, like deletion and insertion. Okay. So to fix that, of course, we do extends slist item, and voila, these are good. Okay, we have all those powers, and now it only remains to us to do print lost items, just as before. We need to fill in our new method. So I'm going to say public void print lost items. And now we're faced with the question, okay, it'll compile, but now we're faced with the question of how do we actually know what got deleted? Okay, how could we possibly do that? Well, somehow we need to know what in the past was deleted, so the most natural approach is let's actually override the delete method, public item delete back, and in this case we need to record, okay, so it's going to be 2 steps. Record the item being deleted. Well, actually, how about this? Delete the item, record the item that was deleted, and of course, return the deleted item. Okay? So compared to normal slist, all right, if we look at what slists delete look like, and this code doesn't matter a whole lot, but it, if you look at what it does, it finds the last item, it deletes it, and then it returns the back item. Okay? So this is the expert at pointers has already written slist. We may not be experts at pointers. We're just writing vengeful slist, so we're not going to try and do a bunch of pointer manipulation. Like, we're not going to try and like copy and paste this in here and da-da-da-da. Instead, what we're going to do is take advantage of the fact that we already have the ability to delete. So I'm going to introduce a new keyword. Okay, so use superclasses method, and to do that, we're going to say super.deleteBack. Okay, that's saying I'm a vengeful slist. But really, I'm also an slist. So I'm going to dig into that part of my brain, tap into the latent, psychic energies within my slist body, and I'm going to say, okay, that part of my brain, do super.deleteBack. It does all this fancy stuff, but we, as the vengeful slist programmer, don't have to think about it, and that's crucial, right? It allows us to specialize our class without understanding all of the inner workings. So I say super.deleteBack. This is the deleted item. Okay. Now I want to record the item that was deleted and ultimately return it. Okay, so how do we record the item? Oh boy. I just realized I have my loud keyboard today, so you're probably enjoying that clackety clack clack sound. Let's switch. Okay, watch this. I actually have another keyboard right here. Please enjoy this moment. Well, it's all kind of tangled up. Okay, this isn't fair. What the heck? Who did this? Alright. Put it on this chair you can't see. Grab this keyboard. Unplug this clacky beast. And we're going. Okay. We keep it real here. It's 61B. Okay. So we're going to record the item. That's what we were doing, as you may recall. What we want to do in this case, then, much better, is put it somewhere. So we need some place that print lost items can actually get the information from. So what I'm going to do is I'm going to say, wouldn't it be nice if we had a place where we could hold items that have been deleted? we actually have a great class that we built ourselves called slist. I'm going to put here deleted items. Okay. And when we want to record the item, we're just going to say deleted items dot insert back deleted item. Okay. And we don't need this comment anymore. And that's the delete back operation. Okay. Now the glorious thing is print lost items can be very simple. All we need to do is tell the deleted items slist to print itself out. And it has this print method because in the previous lecture we made that a default method in the list61b class, though I believe in slist we ultimately overrode it. So we have this print method here we're going to be able to call. Okay. So now what? Okay, I think maybe we're done. Let's find out. Okay. So we run it and we get, wrong one. IntelliJ rookie. Okay, we run this and we get, finished with exit code 1, null pointer exception. I'm getting a null pointer exception right here. So now we're in IntelliJ, right? IntelliJ is great because we have this powerful debugger, and we can do something like click, hey, how about here? So if I hit the debug button, of course, hopefully you've seen this in lab, and now I can step through my code one line at a time and see what's going on. Okay. So after I run all those lines, I can see that, okay, great, I have a sentinel node, all this stuff. I can keep digging through all the pointers if I want. But the interesting thing's going to happen when we go into delete back. So when we go to delete back, okay, we delete the item, and then here, this is where we're going to run into a lot of trouble, right? We can actually already see it's highlighting for us. It's saying deleted items is null. So it is no surprise that if this is null, and we skip to this next step, we get null pointer exception. Okay? So stepping through the code, boom. Right, we hit right there, and we can see that the problem was that deleted items was never initialized. It was always null. Okay. So how do we deal with that? Well, it makes sense that when you construct a vengeful slist, we really ought to build such a thing. So I'm going to say public vengeful slist. Okay. So if someone makes a vengeful slist, what do I need to do? Well, I need to do deleted items equals new slist item. Okay. And so in this case, whenever a vengeful slist is created, we have a holding tank, a place where we can store all those hateful memories of who our fallen comrades are. Okay? So if we try running this again, I took away the breakpoint. I should push. Let's see. Okay. Nope. All right. So I run this again, and now this time I get the fallen R 1310. Okay. So that's our class, right? We built a vengeful slist, and we saw this new cool keyword super wherever it went. There it is. All right. So let's think a little bit about what we've accomplished. We have built this class. It has all of the abilities, all of the capabilities, all of the ape-abilities. I don't know what that means. Anyway, it has all of these things of an slist. Okay. So we have a constructor we built that sets up a holding tank, a delete method which deletes an item, stores it somewhere, and returns the deleted item, and finally a print method that prints all of the lost items. Okay? And remember that super just means call the version of delete back that goes with the super class. Okay? Interesting question you might consider. In fact, I encourage you to download the lecture code, delete the word super, and try and predict what do you think will happen. Okay? And maybe you'll be right, maybe you won't.